Hi everyone, this is Bingchen Zhao, and this talk is about our work, OOD-CV benchmark for robustness to individual nuances in real-world attribution shifts. This work is accepted as an author paper at ECCV22. So the motivation for this work is simple. Deep learning is making a huge progress in most areas of computer vision, but models are mostly evaluated on IIT test data. Their performance in real-world scenarios degrades significantly. So we want to test generalization to OOD shifts, and we annotate 5 nuance variables that can vary independently in images that are shape, pose, texture, context, and weather. We also annotated both 3 vision tasks, that is image classification, object detection, and pose estimation. We collected class annotations, bounding box annotation, and 3D pose annotations for about 500 images per nuances, resulting in a total number of 2,600 images. In the image collection process, we ensure that each image only contains 1 nuance variable. After we have collected the data set, we perform some experiments and have some interesting experimental findings. First is that the negative impact of OOD shifts varies across tasks and the nuances. For example, on image classification, the OOD weather has the most performance degradation, and for object detection, the OOD context is most influential, and for 3D pose animation, the 3D pose of the object is mostly influential. Secondly, we found that strong data augmentations does not help much against our OOD shifts compared to the improvements on the IID performance. And lastly, we compare convolutional neural networks and transformers on our benchmark and found that convolutional neural networks and transformers performs roughly the same on our benchmark. So here's the summary of our work. Our dataset enables OOD tests with respect to change in 5 nuance factors, that is shape, pose, appearance, context, and weather, and 3 different computer vision tasks: classification, detection, and pose estimation. We also have experimental findings that the negative impact of OOD shifts varies across tasks and nuances. Also, strong data augmentation does not help much against OOD shifts. And finally, CNNs and transformers are equally sensitive to OOD shifts in our benchmark. Our code and data are available on GitHub. You can scan this QR code to access it.